Today we're going to talk about Target 6, which is a really important target, not only for this semester, but next semester as well. It's all about factoring. So we're going to just practice factoring lots of different quadratics, and this is going to be our fourth and final way to solve a quadratic. So really, really important notes. Make sure that you understand this before we move on. So just like with the quadratic formula, we're going to talk about what our A, B, and C values are. A is what's in front of x squared, so that's just a 1. B is 8, and C is 7. And so we're going to use those values throughout our factoring process. So step 1 asks you, are A, B, and C all divisible by a number other than 1? So 1, 8, and 7. We can't divide all of those numbers by the same number, so the answer would be no. We can't divide them all by any other number other than 1. If we could, we would factor out that greatest common factor. We will see some cases like that today. But I'm going to write none since we can't divide them all by the same number. So now what we're going to do are find numbers that multiply to A times C. So if we look back at A and C, so A times C gives us 7. 1 times 7 is 7. And numbers that add to B, which is 8. So just pulling those numbers from A, B, and C. So if you think about this, two numbers that would multiply to 7 but also add to 8 would be 1 and 7. They meet both of those criteria. 1 times 7 is 7, 1 plus 7 is 8. So now what we're going to do is use those two numbers, 1 and 7, and we're going to rewrite the original quadratic with B broken down. So this will be 1x. The x is already there, I don't need it. This will be 7x. Now just to kind of recap what we just did, I have x squared, and then if I add 1x plus 7x, that would be 8x, and then I have plus 7. So what I'm doing is breaking down this 8 to the two values that we just came up with, 1 and 7. So I'm going to carry down those numbers to this next step. So here's 1x and 7x. And notice what's different in step 4 is that we're using parentheses to group the first two terms and the last two terms together. So let's look at these first two terms. X squared and 1x. We're going to look for the greatest common factor. So meaning, what can I divide both of those numbers by? I can divide them both by x. And when I do that, I'm left with x plus 1. And then I'm going to do the same thing for the second set of parentheses. So 7x plus 7, I can divide both of those numbers by 7. That would leave me with x plus 1. And now we're at a point where we can actually write our factored form. So if you've done everything correctly, these two parentheses should be the same. That's one of your factors. Here, these numbers, x plus 7, represent your second factor. Now, real quick, I just want to kind of take this over here and almost in like a little thought bubble. What we can do is, if you think about foiling these two together, so using multiplication to multiply those together. So x times x is x squared. Outer, x times 7 is 7x. Inner, 1 times x is 1x. And last, 1 times 7 is 7. Excuse me. And if you combine those like terms, we have x squared plus 8x plus 7. So notice we haven't actually changed what this equation is, we just changed the way it looks. And so then step 6, our final 6, we're going to set each factor equal to 0 and solve those equations. So I'm going to do x plus 1 equals 0 and x plus 7 equals 0. And I'm going to solve. So to get x by itself, I would subtract 1. So one of my answers would be x equals -1. Over here, I'm going to subtract 7 to get x by itself. My other answer would be x equals -7. So these are our answers to our quadratic. That's what our goal is. If we were to use complete the square or quadratic formula, we would get the exact same answers. So flipping over to the next page, we've got a couple different examples going on here. So on this first one, the A value is 2, B is 8, and C is -24. So remember, our first step is to decide, can you multiply all of those, or sorry, divide each of those numbers by the same value? And we can. We can divide them all by 2. So what I'm going to do is put a 2 on the outside of parentheses and actually divide each of those numbers by 2. So that would give me a 1x squared plus 4x minus 12. So we skipped that step last time, but this time it is important. So now for our next step, when we move into step 2, we're going to focus on what's in parentheses. So that 2, that greatest common factor that we just took out, is going to be really important. And when we get down to our factored form, it's still going to be there. It's just not going to impact us on any of these steps. So it won't impact us on steps 2 through 4. So now, remember, we're finding 2 numbers. So we're going to look for 2 numbers that multiply to a times c. Now that we took out our common factor, we actually have new a, b, and c values to work with. So a times c would be 1 times negative 12, which is negative 12. Our b value is 4. So we want 2 numbers that multiply to negative 12 and add to positive 4. Those numbers would be 6 and negative 2. They multiply to negative 12 and add to positive 4. So then looking at our rewrite step. So we have a 2 on the outside of parentheses still, x squared, and then we use these numbers, so plus 6x minus 2x to rewrite 4x, and then it was minus 12? Yeah. So we've rewritten, and now we're going to group. So we still have a 2 on the outside of parentheses, and then I'm actually going to use brackets here. So I'm going to group x squared plus 6x. And I'm going to group negative 2x minus 12. It's always the first numbers and the last numbers, first 2, last 2. And then I'm going to look for the greatest common factor between these sets of parentheses. So we have the 2 on the outside. Greatest common factor in the first set of parentheses is x. That leaves us with x plus 6. Greatest common factor in the second set of parentheses is negative 2. If I divide that, it gives us x plus 6. I know I did this right because the 2 parentheses are the same. And when the 2 parentheses are the same, that is one of our factors. So remember, I carried down that 2 so I wouldn't forget it along the way. So that was my greatest common factor from step 1. Then x plus 6 is one of my factors. The other one is your 2 GCFs, x minus 2. And now we can solve. And so to solve, we take both of our factors, x plus 6, set it equal to 0, and same for x minus 2. So I'm going to subtract 6, so I'm working to get x by itself. So x equals negative 6. And over here, add 2. X equals 2. Okay, so same process every single time. It's just different numbers, so it makes it feel a little bit different each time. On our next one, our A, B, and C values, so 9, 24, and 48. And so all of those numbers, if you think about a GCF, all of those numbers are divisible by 3. So I'm going to divide it all by 3, which means I put a 3 on the outside of parentheses. That would leave me with a 3x squared plus 8x minus 16. And so now I have a new A, B, and C value. A is 3, B is 8, and C is negative 16. So in step 2, we're going to find 2 numbers. So we find 2 numbers that multiply to A times C. So if I do 3 times negative 16, that gives me negative 48. And I want numbers that add to 8. So 2 numbers that would add to 8 and multiply to negative 48, 12, and negative 4 would work for both of those. So now I'm going to rewrite my quadratic using 12 and negative 4. So I had a greatest common factor of 3. and then I had 3x squared, and then I'm going to use my new numbers, so 12x minus 4x, which is still 8x that we started with, minus 16, and then we do our grouping. So I have a 3, and then I'm going to group the first two terms, so 3x squared and 12x. And here's my last two terms, negative 4x minus 16. And then I'm going to look for a common factor. So 3x squared and 12x, they can both be divided by 3x, which would leave me with x plus 4. And then negative 4x minus 16, they're both divisible by negative 4, leaving me with x plus 4. I'm making note that I know I did this right because these two parentheses are the same. They always should be. So now we're going to write our factored form. So we have that greatest common factor of 3. X plus 4 was the factor that was the same. The other one comes from your GCFs, 3x minus 4. And then we solve. So to solve, we're going to set each of those factors equal to 0. So x plus 4 equals 0, and 3x minus 4 equals 0. And we're going to solve. So to get x by itself in the first equation, we subtract 4. So x equals negative 4. And then in the second equation, I'm going to start by adding 4. So I get 3x equals 4. And then I would have to divide by 3. So I get x equals 4 thirds as my second answer. Moving on to the next page, we are just going to go through this. So we've taken away all the steps, and so we just have to go through based on what we remember. So your first step is to decide if A, B, and C are all divisible by something. So we have A is 5, B is 10, and C is 20. And I'm recognizing that we can divide all of that by 5. So we have 5 as the common factor, x squared plus 2x plus 4. So from here, what we're going to do is identify our new A, B, and C. And then we're going to go through our process. So two numbers that multiply to give you A times C, which is 4. Two numbers that also add to give you 2. So two numbers that multiply to 4 but add to 2. There are actually no numbers that meet that criteria. So the purpose of this problem is to show you that there are problems that are not factorable, which is why we show you complete the square and also quadratic formula, because those always work. This one was not factorable. All right, so on B, we have A is 2, B is 11, oh, sorry, B is 22, and C is 60. Look for a GCF, they're all divisible by 2. So we have a 2 on the outside, which would give us x squared plus 11x plus 30. So our new A, B, and C values, A is 1, B is 11, C is 30. So we're going to find two numbers that multiply to A times C, which would be 30, and also add to give us B, which is 11. So we do have two numbers in this case. Those two numbers would be 5 and 6. They multiply to 30, and they add to 11. So now we're going to rewrite our quadratic. So we have 2, and that would be x squared plus 5x plus 6x plus 30. And then in the same step, I'm actually going to group as well. So then we group. So looking for a common factor in the first set of parentheses, the common factor would be x, leaving us with x plus 5. In the second set of parentheses, it would be 6, leaving us with x plus 5. And then I'm at a point where I can write the factored form because my two sets of parentheses are the same. We have x plus 5 and x plus 5. So factored form, we have a 2 out in front. One of our factors is x plus 5. The other one are your two GCFs, x plus 6. And then we go to the zeros, so you set each of your factors equal to 0. And then solve. So I get x equals -5. So when it says zeros, that just means the solutions, the answers. And x equals -6. All right, moving on to C. So on C, we're going to start by looking at our A, B, and C value. And I'm recognizing they can all be divisible by 4, or they all are divisible by 4. So 4, and that would be 2x squared plus 9x minus 5. My new A, B, and C. A is 2, B is 9, C is -5. So I'm going to look for two numbers that multiply to A times C, which would be -10, and also add to the B value, which is 9. So numbers that multiply to -10 and add to 9, those numbers would be 10 and -1. So now we're going to rewrite our quadratic. So 4, that was a 2x squared, plus 10x minus 1x minus 5 equals 0. And now we're going to group. So looking for our greatest common factor, in the first set of parentheses, the common factor is 2x. That would leave us with x plus 5. In the second set of parentheses, they only have a negative in common, so I'm going to say the common factor is a -1, leaving us with x plus 5. And we know we did this right because we get x plus 5s. So we have a 4 out in front for the common factor. One of our factors is what's the same, so x plus 5. And the other one comes from your two GCFs, so 2x minus 1. And now we're going to find the zeros. So x plus 5 equals 0, and 2x minus 1 equals 0. Again, zeros, when I say that, that's just talking about the answers to the problem. So I'm going to subtract 5. So one of my zeros is x equals -5. And then for the second equation, if 2x equals 1, I'm going to have to divide by 2. I'm going to leave that as a fraction. So x equals 1/2. So those are my two zeros. Those are my two answers. Remember, you could always plug those back in for x in the original problem, and it should be a true statement. All right, taking a look at this last one on your notes. Looking at A, B, and C, and we're just going to try to streamline this a little bit so that we don't have to keep writing out A, B, and C. All of those numbers are divisible by 5, I think is the biggest number they're all divisible by. So we would have a 5 on the outside, 7x squared plus 64x, and that would be minus 60. So your new A, B, and C, A is 7, B is 64, and C is -60. So we're going to look for two numbers that multiply to 7 times negative 60, which is negative 420, and add to 64. So these are really big numbers. It might take a second to figure these out, and that's okay. So I'm going to work on this, and you guys also work on this. Okay, so the two numbers would be 70 and negative 6. They multiply to negative 420, and they also add to negative 64. So now we're going to rewrite our quadratic. So we have a 5 on the outside still. Then we have 7x squared. We're going to use our new numbers, 70x minus 6x minus 60. And now we're going to group. So we still have a 5 on the outside. The common factor in the first group would be a 7x, leaving us with x plus 10. And then in the second group, we have a negative 6 as the common factor, leaving us with x plus 10. We know we did this right because the x plus 10s are the same. So now we can write the factored form. So we have a 5. X plus 10 is our first factor, or one of our factors. It doesn't have to be written first. Our other one is 7x minus 6. And we're going to set each of those equal to 0 in order to solve this quadratic. So I'm going to subtract 10. So one of my solutions, one of my zeros is negative 10. Over here I'll add 6. And I get x equals 6/7. And I'm just going to leave it like that. We're trying as hard as possible in this unit to keep our answers exact. So that is target 6, which is factoring.